Hey, welcome to Chapter 9, Lesson 1, Scatterplots. This starts our statistics and probability unit, and our learning target objective for this lesson is to construct and make conjectures about scatterplots. Conjectures, if you do not know that term, educated guess or an idea about a scatterplot. Okay, we have a couple of vocabulary words. Bivariate data, which is data with two variables or pairs of numerical observations. We'll take a look at those as we go through our examples, as well as scatterplot, shows the relationship between bivariate data graphs as ordered pairs on a coordinate plane. Once again, you can always pause the video to write down the definition, and then start the video back up once you are ready to go as we will move forward. Okay, a key concept for this lesson, type of associations. We have variable association and linear associations. We're going to take a look at the graphs that we have. First one says strong positive correlation, which as we would see on here is we have this bottom line would be the x-axis. This would be the y-axis. As you see, as the x goes up, the y goes up. So as we would say, this would be a positive association. Positive association, because as one goes up, the other goes up. Okay, now we're going to take a look down here at the chart right below there as it goes downward. Okay, and you can see all these plot points are mostly going on the downward motion. Okay, and once again, we have our x-axis and y-axis. And knowing as you go left to right on the x-axis, the numbers are going to go up. X is going up, increasing. But as this is going left to right, our y is coming down, so it's decreasing, so y is going down. This would be a negative association. Negative association. Okay, we're going to pop around this chart just a little bit. We're going to look at the top right, which says no correlation. As you can see, the plot points are all over the place. There is no pattern to there. There's not going up or down. And we just call this no association. No association. So you can see a positive association is x and y increase together. It's a positive. A negative one would be x increasing, y decreasing, would be a negative association. And those are types of variable associations. So we'd have positive, negative, and no association. Okay, make sure you understand the concept of those three. If not, replay the video or have questions ready for class in the morning. Okay, we're going to look at linear associations. So let's take a look at a linear association down here at the middle bottom. You can see all the points are going downward, but they're all sort of staying close to the same line and in a line. So that would be a linear association. Linear, as all the plot points are pretty much almost in a line. And our other association for linear association is nonlinear. Points that lie in a shape of a curve. Let's look at the bottom right. As you can tell, these points sort of a curvature. So this would be an example of a non-linear association. Points that form the shape of a curve instead of a straight line. And those are your 5 different types of associations. And we're going to take a minute here to also discuss a couple of things you might have heard in previous class experiences. We have outliers and we have clusters. So let's take a look at one of our graphs here. Let's look at top middle here. And as we see on this chart, we sort of have a cluster. Cluster is a close grouping of data. An outlier, say we have an outlier. There's one point way out there. We'll just make one up. Outlier sort of away from the rest of the group. That would be an outlier. Okay, just make sure you understand outliers just away from the group. We've talked about that in previous lessons as well. And also we have cluster. Cluster is just a grouping of similar data. Okay, now let's move on to our next slide, which is an example. Construct a scatter plot of the number of viewers who watch the new seasons of a certain television show. Okay, you see we have our data in our table, as well as an empty graph. Here we go. We're just going to make one up here. Move along. Okay, first you have to label your graph. First we'll put seasons. We'll put seasons on the x-axis. Put season down there. And we got a big graph. We can always skip a couple spaces here. Let's go 1, 2, 3, 4, 5, 6. Okay, on the y-axis, we're going to call this our viewers. The viewers are over here. Okay, and they are millions, so you always really want to say how we're categorizing them in the millions. Okay, and we start at, what is our lowest one? 22. So we're going to have a little break in the graph. Remember, to show a break in the graph, you sort of put a little squiggly line, so that way it knows there's a break right there. And let's start here at 20, 22, 4, 26, 28, 30, 32. I think that will cover us. Okay, now I'm just going to plot your points. First season, 31.7. So we come up here to the 31, in between 30.7, probably right about there. Season 2, 26.3. So drop some. Come up here to 26.3. Gonna plot that right there. Season 3, 25. Right there in the middle. Season 4, 24.7. A little less. Season 5, 22.6. As you can see, it's declining as we go. 22.6. And the last season, 22.1. Right, almost right there. And there you have your scatter plot. We don't connect any lines. There are no bars. We just plot the points. Okay, let's move on to our next example, a real-world example. Interpret the scatter plot of data for the amount of memory in an MP3 player and the cost based on the shape of the distribution. Okay, so here they just want us to interpret the data. We have to make up the chart. Okay, variable association. Remember variable association? We had 3 types. We had positive. That's when x and y's both increased. We had the negative. X was increasing as y was decreasing, and no association, which there were just points all over. So which one do you think this chart represents the most? If we look along the x-axis, which is the memory down at the bottom, as the memory is going up from left to right, our cost seems to be going up, so our variable association should probably be positive. As you see, these numbers are going up, and the costs seem to be going up at the same time as we get more memory. Okay, let's look at our linear association. Does this form more of a straight line or a curve? I would say if we just drew a line pretty much close to the middle there, pretty much I would say that would be linear association would be linear. Remember our 2 options is linear association or nonlinear. And our last one, other patterns. Do we see any other patterns? Is there a cluster? Is there an outlier? That would be our other patterns we'd be looking for. If anything, you could say we see a clutter right around in here. There's a little bit of clustering of data down in there. So between 1 to 4 gigabytes, 1 to 4 gigabytes, there's a And then the cost is anywhere, looks like from $25 to $75. That'd be our pattern. That'd be our clustering. You could say this one point up at the top might be an outlier by itself, but it's not too far off from the other one. So, and there's how we interpret a scatter plot. We have our 3 different variable associations, our 2 different linear associations, then we're looking for other patterns, either clustering or outliers. And let's take a peek at our last example. Table shows public enrollment. Construct and interpret a scatter plot of the data. If association exists, make a conjecture about the number of students that will be enrolled in public schools in the year 2015. Obviously, this question's a little bit old since we're in 2015 right now, but let's take a peek at this. So we're going to make a chart up once again. Look at our years. We're going to be down the x-axis, and we have up to 11. So as we start there, we're going to go 0. We'll skip 1. 2, 3, 4, 6, 7, 8, 9, 10. And then let's go. We're going to have a break. If you look at the data for a number of students, anywhere from the lowest point looks like at 46.9 million all the way up to 50. So let's we're going to break that. Show a little break once again. 46, 47, 48, 49, 50. Okay, let's check on our points then. We have year 2000, we're at 46.9. So we'll be right about there. 2001, 47.2. Year 2002, 47.7. So it's bumping up a little bit. 3, 48.2. 2004, 48.5. 48.8. 49.1 in 2006. 49.3. Another 49.3 in 2008. 2009, 49.6. 2010, 49.8. And 11 went up to 50. We ran out of room on the 50, but we'll put 50 up there. And there is your scatter plot for there. So now we got to interpret the scatter plot now. So our variable association, do we see as x increases, so does y, and that would be a yes. So we will have a positive association there. Linear association, we have a line, or a non-linear association, we have a curve. And I would say that pretty much would probably be pretty close to a straight line there. Just a slight increase, but that would be more of a line. Mine's not a line, but information's more linear. So that'd be a linear association. And other patterns, do we have any clustering or outliers? Don't really have any clustering, and we don't really have any outliers there, so we just put none. And let's look at our one question there. Yes, it makes a conjecture about the number of students that will be enrolled in public schools in the year 2015. Well, as it increases, it doesn't increase very much. We're talking 4 years from there. If you took a 4-year span, let's take the last 4 years. Take 11, 10, 9, and 8. Going from 49.3 to 50 in 4 years. So that's 0.7 or 700,000 students. So 700,000 students in 7 years. So best guesstimate would probably be in the year 2015, and 4 years add to the last one, which is 50. So I would say about, remember our about symbol, about 51 million students. Okay, this ends lesson 1, chapter 9. Any questions, please review the video or write down any questions and bring them into class.